Hey guys, this is Mr. Ko again, Year 9 Chemistry, and today's lesson is quite interesting because you get to see different observations of different metals reacting with oxygen, water, and acids. Now, if you look at the periodic table, right, what will you see? You see that from the left side to somewhere around here, most of the elements on the periodic table are metals. Now, different metals will react differently because there's so many of them in nature. And this is based on their electrons, how their electrons will behave with its own nucleus and the stuff around them, like stuff like oxygen, water, and acids. Now, you can make predictions on metal reactivity based on the positions on the periodic table, especially for group 1 and group 2. For the transition metals, it gets a little more complicated. There will be some ways you can make predictions, but that's like quantum chemistry. The easiest way is for us to observe it while it's happening and make qualitative observations of their reactivity. So this is what we're going to do. We're going to start off with metals reacting with oxygen. Okay? Open a new YouTube tab and search for lithium, sodium, potassium, calcium, magnesium, aluminum, iron, copper, zinc, silver, gold, and lead. And after you made all these observations, you can search for more metals. It's completely up to you. Just note on the side on your piece of paper and say which is most intense. Which metals will react most violently, and you put various metals at the top, and then which will react less violently, and you put that at the bottom. Okay? You can write the names of the metal paper strips, and you can rearrange them. And once you rearrange them, I want you to come back to me. So, what have you observed? You observed some metals react really violently with oxygen, or not violent, like, boom, but it burns brighter lights. And some metals will appear not to have any reaction at all with oxygen. But what I want you to do now, after you make your table, I want you to focus now on the word equations. General word equations for metal reacting with oxygen is metal plus oxygen gives you metal oxide. So I have provided 4 examples. The most reactive to the least reactive. Potassium and oxygen gives you potassium oxide. The simple equation is K plus O2 gives you K2O. Now balance them. And you will learn how to balance them in class. The next one down, although there are a lot more that's more reactive, and there's some more that's least reactive in between, but I'm just sampling some examples, okay? The next one is magnesium and oxygen. Magnesium, that will give you magnesium oxide. Mg plus O2 gives you MgO. Zinc and oxygen will also react with it, and that gives you zinc oxide. Zn plus O2 gives you ZnO. Now, some metals will not react with oxygen, like silver. Lead will react with oxygen, but not silver. So you get Ag plus O2, no reaction. Alright, I hope that you have already made the tables and recorded it differently. Now, I want you to make observations for metals with water. But before we go on YouTube, let me just talk to you about the general word equation, because Some metals will react nicely with cold water, metal and water, and that will give you a metal hydroxide, and hydrogen as a byproduct. But some metals will not react with cold water, but they will react with steam, and the reason is because when you warm the metal up with heating up the water to become steam, the electrons in the metal will start vibrating and jumping up and down. When that happens, it has a tendency to want to leave the metal. And when steam collides with the surface of the metal, during that collision, electrons may jump from the metal to steam to form metal oxide with hydrogen as a byproduct. Alright, so here we go. Now pause the video, go on YouTube and look at all the different metals I mentioned before and how it reacts with steam and water. Alright? Now, what have we observed? We have observed that some metals, again, will react nicely with cold water, like calcium. There will be others, like the group 1 metals, but I'm not going to go there. Calcium and water gives you calcium hydroxide and hydrogen. Ca plus H2O gives you CaO2, OH2 and H2. Some metals, like aluminum, will not react with cold water, but they will with steam. Give you aluminum oxide and hydrogen. Al plus H2O gives you Al2O3 plus H2. But some metals, like lead, will not react with steam, nor will they react with water. So there you go. So if you rearrange the different metals reacting with water, what have you concluded? You have made some observations from metals in oxygen and metals in water. And you have observed that some metals, like those in group 1, will react very strongly with water or oxygen, and followed by group 2, then aluminum, and then all the various transition metals. Alright? So finally, we're going to observe metals with acids. Now pause the video again and search for all the different metals reacting with acids. Alright, so what have we observed? Again, we observe that some metals, like group 1 metals, will react very violently with acids. And the reason is because when you dissolve acids into water, the acids will dissociate into positive cations and negative anions. This will allow the metal to react with the acid. When the anions in the acids, when the metal and the anions get close together, something will happen. A reaction will occur and you get salt and hydrogen as a byproduct. So the general word equation is metal plus acids gives you salt and hydrogen. Some metals, like in group 1, react very violently with acids. Others will react vigorously. You see a lot of bubbling and fizzing, okay? Like magnesium. With hydrochloric acid gives you magnesium chloride and hydrogen. Mg plus HCl gives you MgCl2 and H2. Other transition metals may not react so violently, like zinc and sulfuric acid. That will give you zinc sulfate and hydrogen, ZnH2SO4 plus ZnSO4 and H2. Some metals again will not react at all with acids, like copper. No matter what acid you give to it, react with it, nothing will happen. And so, after we made all these observations, we have tabulated them from most reactive to least reactive, right? And we're going to talk about that in the next lesson.